So suppose this is the x-axis and this is the y-axis, and this axis about which we have to calculate the magnetic field. We have to calculate the moment of inertia. That is the z-axis. So moment of inertia about z-axis will be equal to Ix plus Iy. Is this all right? So what is Ix? Can you tell me? Ix will be equal to mb square by 12. What is Iy? Can you tell me? Iy is equal to ml square by 12. Hope you understand. So Iz will be equal to ml square by 12 plus mb square by 12. Is this all right? This is Iz. This is Iz. So moment of inertia is equal to, about the z axis will be equal to m into m by 12 into L square plus B square. Is this all right? Good. Now, so this is all about moment of inertia. Is this all right? Now, student, if I calculated the moment of inertia, now we have to go through force net is equal to mass into acceleration. That we studied in the chapter of translation. So F net will be replaced by torque net in this chapter, and mass is replaced by rotational inertia, that is known as moment of inertia, and you understand how to find moment of inertia. Now what is acceleration will be replaced? Acceleration will be replaced by alpha, isn't it? Alpha is known as angular acceleration.
Sir, can you hold it up?
Yeah, tell me.
Can you hold it up, sir?
Can you?
Go a little up, sir, up.
Okay, yeah.
Thank you, sir.
Okay. So net force is equal to net torque will be equal to moment of inertia into alpha. Alpha will be the angular acceleration. Is this okay? So how you will calculate the alpha? Now, suppose I'm giving you example. This is the disk which is rotating about this axis. Its mass is m, radius is r, and you are applying a force of twice f naught on the disk in this direction, and another one is applying a force of f naught by 2 on the disk in this direction. So what is the torque about axis of the disk? Torque about axis of the disk, that will be equal to twice f naught into r. This is the torque of 2f naught, and the torque of f naught by 2 is equal to minus f naught by 2 into r. Is this okay? So it will be equal to 3f naught r by 2. This is the torque. Hope you understand. And torque will be equal to I into alpha. So moment of inertia will be equal to mr square by 2. This is the disk. So its moment of inertia, you know, that is mr square by 2 into alpha is equal to 3f naught r divided by 2. Hope you understand. So here alpha will become equal to these two cancelled out. So that will become equal to 3 f naught r divided by mr square. Is this okay? So that is equal to 3 f naught by mr. Is this all right? Good. Now, this is the disk. At r by 2 distance, the radius of the disk is r. At r by 2 distance, this is the center. You apply force of f naught, isn't it? So find mass of the disk is m. Find alpha of disk about center at the instant zone. At the instant zone. Next one, find alpha of disk about the point which is in contact with ground. Is this okay? Do it fast. So what is the torque of F naught about this point? Because first of all, you need to find our center. So about the center, the torque will be equal to, torque net will be equal to F naught into R by 2. And torque net will be equal to I into alpha. So what is the moment of inertia about the center of this disk? That is equal to mr square by 2, isn't it? Moment of inertia of disk about the center is mr square by 2 into alpha is equal to F naught R by 2. So alpha will be equal to F naught divided by M into R. Is this all right? Now, second one, find alpha of the disk about the point which is in contact with the ground. So you need to calculate alpha about this point. So a torque net will be equal to force F naught into this distance. This distance is basically R plus R by 2, that is equal to 3R by 2. Is this okay? And that will be equal to I into alpha. So I about this point you need to calculate. So what is the moment of inertia of the disk about this point? About the center, the moment of inertia is I naught, that is equal to mr square by 2. Yesterday I told you the parallel axis theorem. This distance is R. So moment of inertia about this axis will be equal to mr square by 2 plus mr square. That is equal to 3 mr square by 2 into alpha is equal to F naught into 3 by 2R. So R cancel out, 3 by 2 cancel out. So alpha will be equal to F naught by MR. Is this all right? Good. Now, angular momentum. So what do you mean by angular momentum? So suppose, dear student, suppose this is the x-axis, this is the y-axis. This is the intersection of x-axis and y-axis. Suppose there is a point which is moving in this direction with v velocity and its mass is m. Suppose this one is r vector. Then angular momentum vector is defined as r vector cross momentum vector, linear momentum vector. Is this all right? So this is the r vector cross linear momentum vector. P vector is linear momentum vector. Is this all right? This is linear momentum vector. So now if you can see it, this is the line of motion. So what is the magnitude of angular momentum? That will be equal to r p mod p sine theta, isn't it? That will be the magnitude of this one. You have to take the magnitude of cross product. So magnitude of linear momentum will be equal to mod of r. What is magnitude of momentum? Linear momentum, that is equal to m into v, mass into velocity, into sine theta. Now suppose if this is r vector, this is theta, Then what is mod r sine theta? Mod r sine theta is this distance. This distance is h, isn't it? So similar to the definition of the torque, the angular momentum is also defined as mass into velocity into r cos sine theta. R sine theta will be equal to h. Is this okay? That will be equal to mh. So angular momentum, magnitude of angular momentum will be equal to mv into h. Hope you understand. What is h? H is the perpendicular distance perpendicular distance of line of motion from axis of rotation. Axis of rotation. Is this all right? So this is the called line of motion. Line of motion means line along which the motion is taking place. Is this okay? That is called line of motion. So h distance is the perpendicular distance from the axis of rotation to the line of motion. Is this all right? So now this is origin 0, 0. Is this all right? So this is the mass 2 kg, which is moving with 10 meter per second. This length is 10 meter and this angle is 53 degree. Find its angular momentum. Angular momentum about origin. Do it fast. This is the longest chapter of class 11th. Longest and toughest as well. Do it. So find its angular momentum about origin. So angular momentum will be equal to this distance you need to find into momentum. So this distance is 10. So this distance is basically, if you write sine 53, this distance is h. So h by 10. So h is basically equal to 10 into sine 53. Isn't it? Sine 53 is 4 by 5. So this is 8 meter. So this is 8 meter. Hope you understand. Is this all right? So its angular momentum will be equal to mass into velocity, that is equal to 20 into this distance h into 8, that is equal to 160 kg meter per second. Is this all right? Do it fast. Next question. Okay, leave it. Leave the question. Suppose this object is, this is the object, this is the axis of rotation, and it is rotating with omega, isn't it? It is rotating with omega. So what is the angular momentum? So at r distance, you have to take a small thickness of dm. Is this okay? You have to take a small thickness of dm. So this dm will have a velocity in this direction, that is equal to v is equal to omega r. Is this okay? dm is having a velocity in this direction, that is v is equal to omega r. So angular momentum of that dm particle will be equal to dm into v into r. Is this okay? So dm will be equal to dm into v is equal to omega into r into r. So that is equal to dm into r square into omega. Is this okay? So just integrate it, you will get an angular momentum. So angular momentum will be equal to omega is constant. So this is out of integration, integral dm r square. So if you remember, dear student, this term is moment of inertia itself, isn't it? This term is itself a moment of inertia. So angular momentum L of a rotatory object will be equal to I into omega. Is this okay? This is a very, very important formula, an important derivation also. This is the angular momentum of rotatory object, that is equal to I into omega. Copy it. Now, rotational kinetic energy expression. Its derivation is also very important for a school examination. So suppose there is a lamina and this is the surface. Sorry, this is the axis and this is rotating with omega angular velocity. So at suppose at r distance, you are taking a thickness of dm. So what will be the velocity of this dm thickness? That will be in this direction and that velocity will be equal to omega r. Is this okay? That is equal to omega r. So what is kinetic energy of dm thickness? What is kinetic energy of dm thickness? That is equal to dk and that will be equal to half into dm into velocity square. That is equal to half into dm into velocity square. What is velocity? Velocity is omega r. So this is omega square r square. Is this okay? So this is actually, if you will integrate it, you will get kinetic energy. So kinetic energy will be equal to omega square, half omega square will be out. So integral of dm into r square. So basically, if you can see this, this is I, and this is called moment of inertia. So kinetic energy is equal to half I omega square. Is this okay? So okay, this is a very, very important formula. Kinetic energy of rotating object will be equal to half into I into omega square. Copy it. Okay, today up to this. Bye. Take care. Bye.